The role of emotions in building intelligent systems is a relevant research challenge that investigates whether it is possible to simulate emotions in machines for self-evaluation and learning goals.
MEI is a virtual assistant that helps medical graduates to navigate their next academic steps. It combines large language models, or LLMs, and anomaly detection to simulate episodic memory. MEI is conceived to support, not to decide. It assists in specific, well-defined tasks, not to replace human judgment.
This application is designed to use AI thoughtfully, ensuring human oversight, simulating simple cognitive phenomena to share experiences across a network of agents. Following principles guide its design: conscious use of AI, shared agent experiences across a network of conversational agents, ability to remember and learn from anomalous situations.
LLMs should not make decisions. They should only handle surface-level tasks and leaving decision-making to another kind of systems.
What is not expected comes as a surprise. In a cognitive motivational model, this leads to a redefinition of those inputs data which have brought to a wrong prediction in order to improve the performance. Surprise means that an organism has failed in anticipating future events. Cognitive processes are triggered by emotions, which play a key role into setting goals, driving achievements, or, when things go wrong, stimulating learning.
Not all agents need access to all data. Machine learning tools and interaction management systems have different requirements. We designed a distributed knowledge graph integrated with an event store and a stream processing platform. In this way, we can trace every interaction and reconstruct the reasons why a machine took its decisions. In our system, we explored matching personality profiles and topic representations to build a personalized experience.
As fast as possible, we host dialogue-related data on edge machines to support real-time interaction and reduce latency. At the same time, we host emotion episodic memory in the cloud, where large-scale asynchronous computation can be performed. Managing data placement and signaling update supports efficient management of complex systems in distributed network.
Simulating the experience of surprise helps identify interesting interaction episodes. We capture those moments, share them across agents, test reusable playbooks, and refine the conversation flow, so the system anticipates a similar situation next time. By closing this loop, simulate, detect, share, improve, we explore simulating cognitive processes and adaptability.
From a technological point of view, deciding which experiences are interesting enough to remember and positioning the corresponding data in the correct place of a distributed environment leads to efficient collaborative services. A cognitively inspired AI architecture is explainable and safe because all its components are interpretable for human examination.
The intervention is based on correctness and functionality criteria. The method was initially set up through a formal analysis to evaluate potential error in LLM rephrasing model. A lot of error typologies were defined to measure the reliability of the two reference models. Then we saw that the model tend to be repetitive either in the same task but also across tasks. We proceeded according to a normatively oriented method by design. We have used a proactive compliance model based on data processing principle, like necessity and proportionality. When moving to a more customized experience, it is essential to integrate technical protection measures such as VPNs, encryption, and anonymization.
Of course, we know that processes like this also involve ethical consideration and the awareness required to use a tool like this in a responsible way.
Learning from its own mistakes is an important feature for AI that has been explored by many past approaches like reinforcement learning. In this project, we explored how cognitive processes inspired distributed graph data representations and message passing among conversational agents to create shared experiences to improve the behavior of entire cohorts of agents.